So we're going to do 4 problems that are using complex numbers or imaginary numbers, and the first one is going to be using addition and subtraction. And so first of all, you have your first term, which is a real number, so it's going to be -8, and then you have a complex or imaginary number that's just -3i. You have an addition sign, so you want to distribute that to every term in this parentheses. So you want to know that it's still negative, but you're adding it and it's not subtracting to make it a double negative. So you're going to be subtracting 1, which is a real number, and then you're also going to be subtracting you're going to be adding -15i. So what you want to do is you want to take both of your like terms, and you know that these are both real numbers. And then you're going to take your imaginary terms, -3i and -15i. And so what you're going to do is just do simple subtraction. So you're going to come out with a -9, and you're going to have a -18i. And so then you're going to put a plus sign here because technically you're still adding it. And what you want to do is make sure that once you have your product, you want to put it in the standard complex form, which is a plus bi, using the real number first, which would be a, and bi as the imaginary, b being that right there, and then I is the imaginary number. So that's our answer for problem number 1. And just remember to always put it in the standard form. And then problem number 2 is subtraction. And what you want to do is, again, you want to distribute this to every single term in the parentheses. So this time, this would be addition, so that's got your imaginary division or addition sign. So what you want to do is that becomes a negative, or a subtraction, or a -5i, and 2 negatives for the regular I become a positive, so you're going to add the I. So you take these, and they're fine, you just pull them out, 4 plus 3i, and that's going to be a positive because there's no sign. So what you want to do is, again, take your like terms, which would be, again, following the form a plus bi. So then the next one that you want to do is multiplication. So that gets a little different. Because when you're doing multiplication with complex numbers, you want to remember that if you get something which is an I squared is equal to -1. So if you end up getting an I squared, you can multiply it by the coefficient, multiply the coefficient by -1. So that'll come out later. So what you want to do is when you have something like this, where you have 2 numbers in parentheses that aren't the same, you can either box or you can FOIL. I like to box, so for the box, you make a box of 4 because there's only 2 terms on each side. So you put 2, and you put positive I, and then you put 6, and then you put -2i. You combine these like terms, so you have 12 plus 2i, and then this, you want to pull that out and say that -2 times the I squared, which becomes a -1, so you want to multiply -2 by -1, which will equal a positive 2, and you want to add that to the like term of 12, so that's going to give you 14. And you remember you want to keep it in standard form no matter what it is, so you have to put the real number first, which would be 14, and you want to pull this positive 2i over here, and that's your product. So when you're multiplying, just remember to, again, keep it in standard form no matter what you're doing. Alright, so for D, you have another complex number, and this time there's a complex number on the bottom and on the top of the division or fraction sign. So what you want to do, if you have this, is you want to find the complex conjugate of the bottom number of the denominator. So what it is because you're finding a complex conjugate, you're going to take that addition sign and you're going to make them with subtraction. So what you're going to do is multiply it by 7 minus I, and what you do to the bottom, you also have to do to the top. So you're going to multiply 3i by 7 minus I. And then so what you're going to do is, because you know that I squared equals -1, because this is already a negative, you're going to take this imaginary -1, because that's a coefficient that you don't have to write because the one is understood. You're going to multiply it by -1, and that's going to equal a positive 1. So you're going to add the positive 1 to the 49, and that means you're going to divide the whole entire answer by 50. So on the top, what you're going to do is, you know that this is also a -1. So you're going to have a 21i, and you're going to do subtraction of -3, and you can take that and multiply by I squared, which, like we said, is equal to -1. So once you've done that, you have 21i plus 3, all over 50. So now you have an answer, but the only issue, it's not in the complex standard form. So what you want to do is it's the same way if you reverse these 2 numbers, because of different properties, it's equal to the same thing. So you want to pull that out, and now you realize you have 3 over 50, which is your real number, and then added to 21i over 50. And then that's fitting your standard complex form, and that would be what happens when you divide the numbers.